Challenge number 191, append argument. For a given function type fn and any type a, any in this context means we don't restrict the type and I don't have in mind any type, wink. Create a generic type which will take fn as the first argument, a as the second, and will produce function type g, which will be the same as fn but with appended argument a as last one. Okay, for example, we have a function type that takes a and b as arguments and returns a number, and the result of append argument with the function type and a third type is we have a, b, and x is the Boolean type we passed into the append argument. All right, that's a bit complicated to understand, this description. I think the example makes it much clearer. Let's check it out in the code. And for that, we have two options. I'm gonna start with the easier one where we can use built-in functions. So function extends a function type that has any number of arguments, and or the bracket arguments is any array, so it can be anything, and it returns any. So this function that we pass in can be any function. And the result type is a function type that has also any number of arguments, which consist of the parameters of the passed in function type, which are spreaded, so we get them all, and x, which is our passed in type A, and the return type is just the return type of the function. This makes all test cases pass. Let's quickly test it ourselves with the test type, append argument. I'm just gonna copy this one. So that is, as we can see, Boolean is appended as the parameter x. Perfect, but let's check out a second solution where we don't use built-ins, because built-ins are basically just complex types that can be built anyway. I'm gonna call it append argument no built-ins, and for that we take the exact same definition of the input parameters, so the same constraints. Just gonna copy that quickly, but the result type is gonna be different. We have to check if the provided function actually extends a function type, and we do this so we can infer the parameters and then also infer the return type, and with this we can now work and basically return what we returned before, a function type with any number of arguments that consist of the inferred parameters and a, and then it returns the inferred return type. And if it doesn't extend a function type, then we also can't append anything, so we don't do anything with never. Append argument no built-ins, number Boolean, also has here appended as the third argument. It's called now args_2 Boolean, so we can also call this x, so it's a bit more beautiful. But as you can see, we don't need the built-in types, parameters and return types, but they do make it a bit easier. But to be honest, it's not that hard to quickly check, does this extend, and then infer the parameters and the return type. Yeah, if you have any questions, let me know in the comments. Otherwise, see you in the next one.
If this video was helpful to you, please like and subscribe. See you in the next one.